So what you see here with chemical equilibrium expressions, they are not difficult. I want you guys to breathe in and breathe out. Think about some of the general rules that you need to know when it comes to chemical equilibrium. The first thing, we're going to start easy and then rev it up. So on this first part right here, where it says, write the equilibrium constant expression for the following reaction. All right, so what do you have in this problem? You've got a chemical reaction that is already balanced. That's one thing you need to know. The chemical reaction should be balanced. If it's not, make sure you balance it. The coefficients that you see right here, those will play a role in terms of your exponents, okay? Those will play a role in terms of your exponents. Hello, OMGs. How are you doing? Thank you so much for your kind words. Thank you. Thank you, thank you. Thank you, Kinsey. Thank you all. So if you see here, all right, for your expression, for your K, your chemical equilibrium constant, let me write it out. It's going to be the products divided by your reactants, okay? Products divided by your reactants. Now, the coefficients that I highlighted in yellow, those are going to be your exponents. What is not part of your equilibrium constant are solids and liquids. So you disregard those two physical states, okay? You disregard those two physical states. So to do this problem, what you're going to do is put the products. And if you don't know, your reactants are on the left-hand side and your products are on the right side. That's what you get as the end result, okay? Your products are on the right side. All right. So what we're going to do, we're going to take the chemical formulas here that you see. So the product, I'm going to put in brackets SO3 raised to the power of 2. And on the very bottom, I'm going to put SO2 raised to the power of 2 and O2 left as is. And this is your chemical equilibrium constant expression for this reaction. Okay? That's it right there. Now, if I gave you numbers, then all you would have to do is plug those numbers in. All right? So again, why the exponents are necessary is because that tells you the value that you use from your coefficients to plug into your constants, okay? Those are going to be a part of your reaction. The coefficients are necessary because they are part of your exponents that you have to raise each of those concentrations to. All right? So if we do another problem like number 2, okay, I'm going to go ahead and scroll right here to number 2. We're going to use some numbers here that will explain all of that, okay? So here's number 2. Again, you've got this reaction right here, okay? This is your reaction. N2 plus 3H2 is at chemical equilibrium with 2 moles of NH3. So, excuse me, what you're going to do right here, again, I'm going to look and notice that these are my reactants right here on the left side. So R is for reactants. Your products are on the right side. Because they want you to calculate the chemical equilibrium constant, you're going to say Kc equals NH3 raised to the power of 2 divided by N2 times H2 raised to the power of 3. Now, what you're going to do is plug in the actual numbers, okay? So now I'm going to plug in my NH3. So look at the numbers that they gave you, okay? This is all in a 2.0 liter vessel. You've got nitrogen, hydrogen, and ammonia. So that NH3 value of 0.35, that's going to go on the very top. So 0.35, and I'm not going to use the units because the units are going to cancel out anyway. And because we're talking about constants, constants don't typically have units anyway. It's just the number. So we squared that value, and on the very bottom, we're going to put 0.20 times 0.60 to the power of 3. Okay? Now, let's go ahead and do the top number right here. All right? Now, what you're going to do, you're going to take the 0.35 and you're going to square that, and we're going to put that in right here. So this is going to be equal to 0.1225. That's your top number. 0.60, we're going to cube root that, okay? And that's equal to 0.216. That, not cube root, excuse me. You're going to 3 times that number, all right? So you're going to take the 0.216 times 0.20, and you're going to get 0. I'm going to pull this down so that way you guys can see, okay? You're going to end up with 0.1225 divided by 0.0432. Now, you're going to divide these two numbers, 0.1225 divided by 0.0432. And you get, for your KC, your equilibrium constant, you get 2.836. Okay? That is your answer right there. 2.836. Okay? Now, if we go back to what we had above, for our final significant digits rule, our answer would need to be in 2 sig figs because the concentrations that they gave you were in 2 significant digits. So yes, Francesca, you are correct. 2.8 is the answer, okay? 2.8 is the answer. Okay, so now let's go to this next example, number 3. Okay, number 3. Again, I'm going to make... All right, now remember, for an equilibrium expression, in order to set it up, you've got to make sure you've got the right things in place. Remember, we do not consider solids nor liquids. In this case, we don't have solids nor liquids. But you also know that the formula is products over reactants. Products over reactants. So therefore, we're going to say, all right, well, if we know it's products over reactants, the products are on the right side. The reactants are on the left side. So therefore, my equilibrium constant is going to be NO raised to the power of 4 times H2O raised to the power of 6 divided by NH3 raised to the power of 4 times O2 raised to the power of 5. Okay, let's find the answer that this is equal to. So if we should have NO and H2O on the top, let's go ahead and cancel the answers that don't show that. So letter A shows NO and H2O, so we could consider that one. B, NO and H2O is on the top too. But letter C has NH3 on the top, so we're going to get rid of that one. We don't need that one. And letter D, it's got the right numbers on the top, but let's see if the right numbers are on the bottom. So for the bottom, you need to have NH3 raised to the power of 4 and O2 raised to the power of 5. Let's see if we can find that answer now. We know it's not letter A because letter A did not consider any of the coefficients. So let's go ahead and get rid of letter A. Guys, when you take a test, if you ever have a multiple choice test, if there's 4 answer choices, 2 of them are automatically wrong and the other 2 are automatically possible. So get rid of the 2 that are wrong. And that's what we just did. Now we're looking at letter B or letter D. We need to have 4 and 5 on the bottom, 4 and 6 on the top. The answer that we see that should be the correct answer is letter B, because there's a 4 and a 6 on the top, and there's a 4 and a 5 on the bottom. Letter B. So guys, you see how simple this is? You see, it's not that difficult. You just have to concentrate on what you're given, what is required, what is the proper setup. Yeah, very simple. Exactly. Very simple. All right, y'all. We're going to do another one. We're going to keep practicing this because remember, if you don't understand the foundation, guess what? You're not going to understand anything else that you have to do as it relates to these chemical equilibrium problems, along with the ice chart. Okay? This is your next problem, and I want you guys to do right here. Number 4.